and we look at conduction in different materials. We had some steel bars and some aluminum bars, some of these black temperature strips, some water, the foam cups, and some thermometers. Okay, we went through our starting temperatures on the steel and the aluminum. We're somewhere around those. Some of the things that we're going to be looking at is what happened to the bars when we put them in the metal strips, looking and touching the metal bars to feel the temperature change and how well they conduct or don't conduct heat. Here is the lab that we were doing in class. So I have the video of this. We can see we're starting off with a steel bar and an aluminum bar, and we have them at room temperature right around that 20 degrees Celsius. Here is the steel bar and the aluminum bar. Okay, and we're going to put them into our cups of hot salt water. Okay. You see I dyed the water a little bit there to make it easier to see where the level of the water is. As they sit in the water, okay, we notice that the 2 cups of water are very, very close to 70 degrees Celsius, one slightly above and one slightly below. We start to notice the aluminum here on the left is heating up faster, and the steel on the right is not heating up quite as fast. Okay, remember that first of all, there is no cold, only heat. We perceive cold as actually low levels of heat. When you hold an ice cube in your hand, the cold doesn't go into your hand. The heat energy goes out of your hand and into the ice cube. Heat is the motion of atoms and molecules. The greater the motion, the more heat energy there is in solids, liquids, and gases. Okay, when material 1 with lots of heat or molecular motion comes in contact with material 2 which has less molecular motion, the energized molecules in material 1 bang into the molecules in material 2. As a result, the molecules in material 2 then get an increase or start to move faster or have an increase in heat. So we could see here the aluminum bar is heating up very, very thoroughly all the way through right to the top, and the steel bar is not heating up very much at all. Very, very inconsistent, doesn't transfer the heat very well, doesn't conduct the heat very well. The molecules in material 1, when they transfer that energy from the water to the steel bar, are going to have less motion or less heat as they transfer that energy, and they're then going to end up at a cooler temperature. And we can see we start off closer to 70 degrees, and now we are definitely below 70 degrees at each one. The energy transfer happens between the molecules or atoms until when they come in contact. So in that case, what we were looking at there was the water in contact with the metal bar, so we're watching conduction taking place. This kind of heat transfer from atoms coming in contact with each other or 2 different materials coming in contact with each other is again conduction. Looking at the results of the lab that we did here, what happened to the metal bars when we placed them in the metal strips, we've seen the temperature strip indicators increased and moved up the bar, so that color transferred all the way up. The aluminum bar got hotter faster. We've seen that transferred all the way up to the top of the bar, and the steel did not. Feel the 2 metal bars. How did they get the heat from the water to the temperature strips far above the water level? Kinetic energy in the water transfers to the metal by conduction. Okay, heat conducted from molecule to molecule in the metal to move it upwards. So once that heat transferred from the water to the metal, then it transferred within the metal all the way up to the tops of the metal bars in the case of the aluminum, and almost up to the top in the steel. And we should have noticed that the aluminum did transfer all the way up and was warmer than the steel when we did touch them. Okay. Did the metal conduct heat? Obviously, yes. Which metal is a better conductor, and why do we think so? Both metals conducted heat. The aluminum was a better conductor. The heat moved up the bar faster and went further. So that's why we look at aluminum as a better conductor than steel, because the heat did not transfer as thoroughly through the steel, and it transferred all the way through the aluminum. So if you have any questions, again, please feel free to stop by in class and ask.